Welcome, folks. In this video, we're going to show you how to create a computer-generated fractal image. To get started, we're going to take a look at a fractal formula. Now, this formula we happen to be looking at is a very popular formula. You're liable to find this in other forums on the internet. In this formula, this is simply saying that x equals x times x minus y times y plus a. And y equals 2 times x times y plus b. Now, a and b are numeric constants that are set ahead of time. You can set those to any different number, and you will wind up with a different image depending on what those numbers are set at. Now, there's a lot of confusion over how to use these formulas, so that's what we're going to talk about today. To get started, we need to insert our fractal formula into a computer algorithm. Now, you'll notice these two lines right here, that is our fractal formula. And we've inserted that into a for next loop. And that loop is going to loop through up to 18 times to make a determination of whether a particular pixel needs to be colored white or black. If you come over here and notice what we did before we came into this loop, we've assigned x equal to the value of px. So for example, let's say we wanted to determine, is this pixel going to be white or black? Well, the value of this pixel, let's say, is 1, 1. So we would insert px would be 1, py would be 1. That would get assigned to x and y. Then we would go through this iteration, and every time we go through, we're going to recompute a new value for x and a new value for y. And as we go through this loop, one of two things is going to happen. The x value and the y value are either going to stay below infinity, or one or both of them is going to head off towards an infinite value. Now, that could be an infinite value in the positive direction or an infinite value in the negative direction. But either way, if either of those spin off towards infinity, then we're going to color this dot white. If not, if we make it through 18 iterations and neither of these values is spun off towards infinity, then we're going to color this dot black. All right, now what we're going to do is actually put that formula to use. Now what we have here, there's a little bit of source code here. It just goes from there to there. This is the entire program we're going to show you. This source code happens to be written in ClipperBASIC. That's the ClipperBASIC programming language. Information about this language is available at this address right here, at theclipperbasic.com. But everything you need, the software that you need, along with a copy of this source code, is actually stored in this Fractal Fun, this zip folder right here. It's got right here, this is the application, this is the ClipperBASIC runtime system that will compile this source code and run it for you. And then this Fun with Fractals right here, that is this source code. So that's this code. This is downloadable, this whole folder. There's a link to this folder right below in the comments section of this YouTube video. So if you just click on that, you can download it. Now, the ClipperBASIC language does require a Windows XP or Windows 7 machine. Might work under some other Windows environments, I'm not really sure. But and if you don't have Windows, or if you're using some other computer, you can follow the logic. All right, so let's take a look at this subprogram. This is our subprogram Fractal. Now, this has our algorithm in it, where it says right here, compute and draw fractal image. Everything from here down to here, this is the algorithm that is actually going to take our fractal formula. Now, notice right here, these two lines of code right here, this is our fractal formula. Notice that it is in this iteration loop, this for I equals 1 to 18. This is going to iterate it up to 18 times. If either the x or the y spins off into either an infinite positive or an infinite negative direction, it's going to trip a flag and exit the loop. Now, for anyone wondering how do we compute this infinite positive and infinite negative, I'm going to scan up right here. This right here is the logic that in ClipperBASIC will generate a positive infinite floating point value and a negative infinite floating point value. And we did that so that we can then compare x and y to find out if they've gone infinite on us. All right. So now the thing is, what we're doing is, notice here we're counting for I equals 1 to 18. So every time we go through there, the first loop I is 1, second loop I is 2, third loop I is 3. And we are using the number of times that it went through to determine what color to set the pixel. Okay? Now if it gets all the way to the bottom and it doesn't trip the flag, it's going to exit at 18. If the x and y did not spin off, then we said it was a black pixel. So notice here, if the flag is tripped, then we're going to set it equal to some color. And if not, we're going to set it equal to 0. Color 0 happens to be black. Okay, and then we're going to, next line down here, it sets the color, it sets the pixel. So we're going to scan for py is 1 to the graphic region height, for px is 1 to the graphic region width, and these two loops are going to scan every pixel in our image. And then for each pixel in our image, we are going to determine what color to set that pixel, okay, based off of what's going on right here. All right, say it took 5 times to go through this loop to hit this infinite value. Then we are going to use the color which is in our color array at 5. And let's go up and take a look at our color array. Notice what we've done here. We've taken the first 4 because it takes a while. I mean, it takes a few iterations before something's going to happen. But if we go infinite in less than 4 iterations, we're going to go color white. If it only takes 5, we're going to turn it red. If it only takes 6, orange, 7, yellow, and through here. Now, we've happened to create the rainbow colors. Those are the colors of the rainbow. If it were to make it all the way up to 12 to 18 and hit an infinite value at that level, then we're just going to say pink, because you're going to find out that very, very few things will actually get into that. But most of what we're going to hit, it's going to hit these different colors. So let's just go ahead and run this and show you. Okay, now this here, this is the fractal image for these settings. For A as a 3, B is -11, and a magnification level of 6. Now the first thing I'm going to do is I'm going to show you what happens is if we say we want to go down. We want to move the viewer down, but let's say 300 pixels. Okay? And then we're going to go ahead and compile and run that again. Notice what happened. I've got 2 screens going here so you can see both of them. All right? Here's the first one we did, and we had all this black. All right? So what I did is I said, well, let's move the viewer down. Think of this as your viewer. You're looking at your fractal image. We moved the viewer down by 300 pixels. And when we did that, now we're looking down lower in the image. Okay? Now let's say we keep it there, but we want to take the magnification. We want to back the magnification off, let's say to 5. And let's rerun it. And you can see you're backing up on the image. Okay? I can take the magnification way out. Let's take the magnification down to 3. Compile and run this. You see what it's doing? Now, notice I left this set. We still have the viewer pointed down by 300 versus being dead center on the axis. So I'm going to go back to dead center on the axis, compile and run it again. So now you're looking, the center of the screen, the dead center of the screen is 0, 0 in the actual field. So, and the reason why it's 0, 0 is because we have the shift right here. This logic right here is taking your center point both vertically and horizontally so that the center of the image is 0. Take the magnification level down to 1 and rerun it. And we'll back it off even more. Let's take it down to 0.20. Go ahead and run that. So you see, we're zooming out. We're moving away from our fractal image. And the last thing I'm going to do is I'm just going to explain the basic concepts of ClipperBASIC for anyone who's not familiar with this. ClipperBASIC, the captain, the sub-captain, the captain subprogram always gets executed first in ClipperBASIC. So what we've done here, this is just a remark. A line starts off with an equal sign or a minus sign. It just means it's a remark indicator. CLS is clear the screen. This here, we're setting the width and the height of the graphic region. We're multiplying this out, 76 times 12. These pixels, if we go into ClipperBASIC and click on this and see that just the text underneath, and this is the grid snap. You see these grids here, okay? That's a text grid. You can actually type into that grid. So what we've done is we've laid this image out starting right here at column 3, row 2. And notice right here, we've placed this graphic region at 3, 2. So what's happened is we told the ClipperBASIC language we wanted to create a graphic region. We wanted it this wide by this high, and because each one of these little text boxes here is 12 pixels wide by 20 pixels high, we basically said we want to have a graphic region that is 76 columns wide by 18 rows high. And so this command, open graphic region, gave us a graphic region that we could then draw our pixels into. And then when we placed that graphic region, we placed it, the graphic region, the handle that was given here. VTG, you have to go to the notebook to explain that. That should just be 0 for now. And because we have not assigned a value to VTG, it is 0 by default. And then we're placing it at 3, 2. So that's column 3, 2 down. So that's the logic of how this graphic region got created, why it got placed here in this runtime window. This is where we set up the floating point infinite values. This next thing is our global array of colors. We've dimensioned the color integer array to have 18 elements. That means the top element is 18. And then we've assigned the values. These color white, that just creates an integer value equal to white in the color. And that's these color commands do the same thing. Then we're calling the subprogram Fractal. So this call Fractal, it calls Fractal down here. That executes this subprogram, hits end sub, comes back up here, then drops down. This catcher, if there were any errors that got generated, this is going to catch it, and this happens to just print out an error message. If you ever want to see this work, you could do something like a equals 3 divided by 0. And because you can't do 3 divided by 0, if we were to compile and run this, it threw an error. And I can come back over here, take the text off, or take the graphic off, I want text only. You notice right here it says you had a divide by 0 error. and it occurred at line 40, comma 1, colon 1. At the log, if we come down to the log, go to line 40, right there it is. Notice the compiler, when the compiler compiles your stuff, it assigns line numbers to everything. So that's how that works.